So question 4 has several expressions that we're asked to simplify. I'm going to try and uh, explain this using best practices. My goal here is for you to be able to handle any problem with similar attributes, not just a particular problem. So the first thing we'll look at here is A, and you can see in A, we have its multiplication, right? It's a monomial times a monomial. You'll observe that there's no addition or subtraction happening anywhere within this problem. In terms of coefficients, I have the number 3 and I have the number 4. And when I multiply those, I do definitely get a value of 12. 4 times 3 is 12. The other thing that I can see is I have some factors of x. In fact, in this first monomial, there's two factors of x. That's an x times an x. And this one has also two factors of x, which is an x times an x. When I put those together, right, that's four factors of x. X times x times x times x. And our notation for that is x raised to the fourth power. This is literally four factors of x. The other thing that we observe is that we have a single factor of y and being multiplied by five factors of y. And if I was to write all of those out, right, a y and then times five more y's, there's exactly six factors of y. So this is times y to the sixth power. So I don't need to rewrite that. I'll just grab this and whoops. You're like, okay, that's interesting, Mr. Roberts. Why don't you just rewrite it? Well, next time I will, now that I know. So that's the answer for A. Let's go on to B. When I look at B, I'm trying to identify common factors within both the numerator and denominator, because once I identify those common factors, it's easy for me to build giant ones. And I understand that the value of 1 when multiplying doesn't change anything, so we can just consider those to be 1s and leave them alone. The number 16 is 2 times 8. And also I notice I have four factors of x in the denominator, so I'm going to rewrite this x to the seventh power as x to the fourth power times x to the third. Now please focus on this. 16x to the seventh and 2 times 8 times x to the fourth times x to the third are exactly the same. They're both 16x to the seventh power. The reason why I've written it this way is because now it makes it easy for me to identify the fact that I also have a factor of 8 and x to the fourth in my denominator. And you can see it, right? This turns out to be nothing more than the number 1. So living in my denominator, the only value I have left is that 1. And in my numerator, I've got 2 times x to the third power. So the answer for B is 2x to the third power, and I'll write that over here, 2x to the third. Let's look at part C. If I look at C, it tells me that I have exactly three of these 3x cubes, right? This 3 that I've written in this pink color tells me how many of those things I have, and what I have are 3x squared. So if I was to expand this, I could write it as 3x squared times another 3x squared times another 3x squared. And it's not always necessary to do this, but it's kind of instructive to do it occasionally. If I reorder this, right, using the commutative property, and I just threw that out there. I believe most of you understand that 2 times 5 is the same thing as 5 times 2. What that allows me to do is just rearrange all the factors in a multiplication problem, so that I can group them in a different way. So I have 3 times 3 times 3, and then I have an x squared times an x squared times an x squared. So I have 3 times 3 is 9 times 3 is 27 times x raised to the sixth power. There are exactly 6 factors of x there. So that was 27x to the sixth power. And the final problem here, part D, best practices. Always consider eliminating negative exponents. So I'm going to do that. I'm going to neutralize this negative exponent in my denominator by multiplying it by b to the third. Now, I can do that if I'm clever and I multiply the numerator by b to the third also, right? If you think about it, instead of removing a giant 1, I've introduced this giant 1, and I understand that when I multiply by 1, I'm not changing the value of my expression. So, provided that b is not 0, that's a slight disclaimer. But anyways, that's not the time for that, sorry. In my denominator, if you look, what I have is I've got b to the 0 power, b to the 0 power, and in my numerator, I've got b to the, there's 2 factors of b, and then 1, 2, 3, so I've got b to the 5th power. The beautiful thing about b to the 0 power is it equals 1. So this is b to the 5th power over 1, or simply b to the 5th power. So the answer to D is b to the 5th power. And those are our 4 answers for question 4.